Let's understand interrupt handler now. So interrupt handler is a function basically which get invoked whenever our Linux kernel receives an interrupt request. So Linux kernel basically has to identify the interrupt, and he has to identify like which hardware actually generated the interrupt, which hardware actually initiated the interrupt, and depending upon the hardware device which actually generated the interrupt, Linux kernel has to basically invoke the respective interrupt handler function. So this function also called ISR. ISR meaning is like interrupt service routine, because this function basically, as I said, it will be invoked as per the response to the interrupt request. So we will be servicing the interrupt into this function. That is why this function is called ISR. So you can take example here. Let's say you have CPU, okay, you have here keyboard device, okay, then you have here kernel, okay. So kernel has already idea about which function he has to invoke once he receives interrupt from the kernel. So let's say we give the name of key handler. So we keep the name key underscore handler, the name of the function which will be invoked whenever there is an interrupt from the keyboard. Okay, so keyboard has generated one interrupt to the CPU. CPU basically has given the same notification to the kernel. Okay, so now kernel will go through the list of interrupt handler which are registered, and depending upon it will come to know, okay, so this keyboard has generated the interrupt, okay, then it has to basically invoke the interrupt handler which is registered for this keyboard device. So it will be invoking this key underscore handler which was registered for this keyboard interrupt as a response of this interrupt which is coming from the keyboard. So this function key handler is called ISR, interrupt service routine or interrupt handler. Okay, and our Linux kernel basically divide interrupt handling or interrupt handler into two parts. One part is called top half, other part is called bottom half. So if you want to understand the meaning of this, top half is the function basically which is going to perform the time critical stuff which has to be performed at the same time when we receive the interrupt, and bottom half are the non-critical stuff which Linux kernel can perform at the later stage whenever our CPU is free. Okay, so why the bottom half was introduced, why the top half was introduced, that we will be discussing sometime later in this training program. In detail we will discuss what is the use of bottom half, what is the use of top half. Okay, so let's understand what exactly the stuff we perform in top half. So you take example of network card basically. So whenever we receive network packet, whenever our system receive network packet from the external card, so what happens is our main job is to basically copy that packet which we received from the outer world to the local buffer, and then giving acknowledge back to the device basically who is generating or giving this packet to the Linux kernel. Okay, so that is the time critical stuff. We cannot delay performing all these operations. And then comes to the bottom half part. So after receiving the packet and copying that packet into the local buffer, at later point of time we can basically process those buffers as per the requirement of our system. So this processing of the buffer anyway we can delay, because at any moment or any point of time we can basically because now the buffer and packet with us, right? So we are basically we are having a freedom to basically handle or execute those buffers at later point of time. So whenever our CPU will be idle, whenever we don't have much priority work to do, at that time we will be scheduling our bottom halves. Okay, so now you understand by the example. So copying of buffer to the local copying of packet to the local buffer, that will be performed as a top half, and then executing or processing those packet which we have received from the network, that is basically part of our bottom halves. So this is how interrupt handler divide into the top halves and the bottom halves. Okay, so now let's understand how the interrupt handler are registered with Linux kernel.